Chapter 4, Lesson 28 is going to be finding what's a polynomial and what's not. And then from those polynomials, finding intercepts. And along with intercepts, we have this piece that's going to be called multiplicity. All right, so when you're determining whether something's a polynomial, this would be the form that it would take, which looks like a lot of stuff here. But when you do the stuff that needs to be filled in here, the coefficients in front need to be real numbers, so you can't have like 3i in front. And your exponents can't be negative, fractions, or decimals. So you can have x to the third, x to the fifth. You can't have x to the 2/3. You can't have x to the negative fourth. So the exponents have to be whole numbers. All right, so identifying it's pretty simple. So you first of all take a look at all the coefficients. So on this first one here, 3, -4, 2, and 5, those are all real numbers. And then your exponents are 5, 4, 3, and then the variable at the end of this would be x to the 0. So all of those are whole numbers, so therefore this one would be a polynomial, and this one would be as well, 3, 5, and -10, and your exponents are all good. Then degree is the highest exponent in your problem. So this one would have a degree of 5, this one would have a degree of 2. All right, these two, neither one of these would be polynomials because on this one you've got 1/3 for a fraction. And on this one you've got a negative exponent, so you can't have that. So both of those would be no. This one here is the one that throws most people off. This one is yes, because this would be the same thing as -5x to the 0 power. And so because of that, you would have your 0 there, and you've got a real number in the front, so therefore this one would be yes, and the degree on that would be 0. And then this one, if you were to multiply it out, which you would need to if you're writing it as in polynomial form, so this would be 6s to the third minus 3s. Again, it fits under all the stipulations, so this one would be yes, and the degree on that thing would be 3. Because again, you'd have 6s to the third on this one here. All right, polynomials would look something like this. You've got a continuous curve. It's smooth. There's no direct changes in direction like this one here where you've got this corner. You can't, on a polynomial, have any gaps, and you can't have any holes. So when you're graphing polynomials, you're going to have your x-intercepts, your y-intercepts, and at the x-intercepts, where it touches or it crosses, we're going to be talking about that over the next couple of sections when you go to graph these things. And then spots that are above the x-axis or below the x-axis would be the other thing that you'll talk about as well. When, again, and we talked about this in earlier chapters, when you're dealing with your intercepts, make sure that you list them all. If it says intercepts, make sure you list the y-intercept along with that as well. All right, so I want to find a polynomial of degree 3 whose zeros are -4, -2, and 3. All right, so degree 3 means that if I were to multiply it out at the end, the highest exponent should be a 3 on that. So what I'm going to do is I'm going to take each one of these, set it equal to x. So x equals -4, x equals 2, x equals 3. Then I'm going to take those numbers on each one of those and move them over to the left-hand side. So I'll add the 4, I'll add the 2, and I'll subtract the 3. So now you'll get those. And then I'm going to write it as multiples here. Each one of those things multiplied together would end up equaling 0. And so your polynomial would be that. Now, if you could multiply this out. Some of those are going to get too long, however, so I'm not going to make you multiply those out in most instances. If you were to multiply this thing out, you would end up with x times x times x, so that would be x to the third, degree of 3, like you're supposed to. All right, multiplicity means that an answer occurs more than one time, and the number of times it occurs is its multiplicity. typically, if an answer only occurs once, which would give it a multiplicity of 1, we don't list that multiplicity, but you could, okay? So we're going to use this polynomial here, and we'll talk about multiplicity on the second question that comes below this. All right, if you remember from an earlier chapter, finding intercepts, if I want the y-intercept, I set the x is equal to 0, and if I want the x-intercept, I set the y is equal to 0. So for the y-intercept, I would put 0 in for the x's into both of these spots here. So you would have 0 times 4 cubed times 0 minus 2 to the 4th. So 4 cubed times negative 2 to the 4th would be 64 times 16, so 1,024. So your y-intercept then would be at 0, 1024. All right, x-intercepts. And then tell what their multiplicity is, and specifically on this one, it's asking for its even or odd. So we'll talk about that here. So the first thing you do is find your x-intercept. So that means you're going to set this equal to 0 here. So you're going to have 0 is equal to that. So you take each one of those and set them equal to 0. So on this first one here, you would get x is equal to negative 4. And with that 3 as the exponent, the multiplicity would be 3, 3's being an odd number, so that would have odd multiplicity. And then for the second one, you would have x is equal to 2, so that x-intercept would be a 2, 0. With an exponent of 4 being an even number, that thing would have an even multiplicity. So if you were to multiply this out, and again, that would be a lot of work, you would end up with an exponent of x to the 7th. You have x to the 3rd, x to the 4th, multiply those together, you get x to the 7th. So that means you should have 7 answers. Well, we only have 2 answers, but this one occurs 3 times, and this one occurs 4 times for your total of 7. So again, this one's not asking for the actual multiplicity, it's asking whether it's even or odd, which is going to make a difference when we go to graph these. All right, same thing on this one here. Find the y-intercept, so that means I would plug in 0 for the x's. Well, if you plug a 0 into this spot here, 0 times all of these things is just going to be 0, so you're going to have a y-intercept at 0. X-intercept, so put 0 in here, so you would take each one of those and set them equal to 0. So this one would be 0, this one would be 3, and this one would be negative 2. So 0 with an exponent of 3 on it would have an odd multiplicity. 3 with the 2 on there would have an even multiplicity. In the negative 2, there would be an understood 1 here. So 1 would be an odd number, so that'd have odd multiplicity. The degree on this, by the way, would be 6, because you'd have x to the 3rd, x squared, x to the 1st, put those together, 3, 2, and 1 put together would give you 6. So the degree on that would be 6. And there's a little joke down there if you want to pause and read that. Okay, so things that you should be able to do when you do the homework, you should be able to tell whether something's a polynomial or not, and then find the intercepts, and with the x-intercepts, find their multiplicity. So that is lesson 28 from chapter 4. Let me know if you have any questions.